Hello, sorry.
Hello, Professor.
Hi, how are you doing?
Good, how are you?
Good, thank you. Sorry, I just finished with a couple of students that stayed a little long for some help, but um, okay, let's check out our lab for today. We are going to do Fibonacci. And then let me open up my REPL. So you should also open up your IDE. So today we're going to spend a little bit of time just working on recursion and looking at Fibonacci. Okay, let me share screen. So just to give you a little bit of background, if you're not familiar with Fibonacci, university and colleges classes in computer science usually use Fibonacci because it's one of the sequence that's easily explained. So you see Fibonacci in nature, in the universe, in design, in a lot of things. I did put a little TED Talk link here, so when you get a chance, the person who did that, he is a math faculty and he explains it really well and how Fibonacci is related to the golden square and other sequence. Since we just finished the sequence information chapter last week, we will also use this to learn about programming and using recursion. So Fibonacci sequence examine the numerical pattern that is described in nature, in sunflowers, in seashells. So this is why when you look at discrete structure book covers, you often see a seashell, or if you're looking at cactus, or a lot of different things in nature, you would see Fibonacci. Sorry, give me 1 second. Let me turn on my firewall. All right, so the Fibonacci sequence, sometimes you would see that it starts with the 0 and a 1. So the base values are going to be 0 and 1, or sometimes you would see them being started with 1 and 1. Okay, so how do we get all the subsequent value is we are going to take the prior two values and add them together. So 0 plus 1 is going to give me a 1. And then 1 plus 1 is going to give me a 2. And then 1 plus 2 is going to give me a 3, and so on. So you simply just take the previous two digits and add them, and that's how you're going to get the next. Okay. So depending on the sequence, you often see that they start with 1 and 1 instead of 0 and 1 because it doesn't make a difference in that. So depending on your seeding values, that's where we would start. So in our sequence, we're going to see that we are going to start at a certain value, either 1 or 0. So we would start with a 1. Okay. So we would look at how that would be related to the recurrence relation. So the way that we write our function would be f of n is going to be equal to f of n minus 1 plus f of n minus 2. So this is the number from two positions from the f of n, and this is the number one position prior to f of n. Okay. And the subpart to this, it talks about how, sorry, I'm in the classroom. Fibonacci sequence is named after Leonardo of Pisa, and he came up with the sequence, but in documentation, they had discovered that it was actually established prior in the Indian mathematics. So when is it really used? You often see this used in data structure, in graphs, in cubes, in parallel system, and in distributed systems. So that's why it's repeatedly being mentioned in different classes in computer science. And we already talked about the biological makeup that is representing Fibonacci numbers. And Fibonacci numbers is slightly different than Lucas numbers in that Lucas numbers have different sum from the prior values. Okay, so the seeding is a little different. So when we're looking at the Fibonacci induction, you can look at the PDF that I attached to the lab if you're interested in the proof for it. Okay. But when you're looking at the program, and in the past we talked about using the .h file. So let's look at, I don't know why it took me to unit 7. I'm sorry. Give me 1 second. Okay. So for the first lab, when you look at the program, and it's fairly a short program, doesn't take very long. You don't have to use the .h, you can just do 2 things. So to replace the .h, you can use include IO stream, include algorithm, okay? And then we're gonna have using namespace std. So we have a function called fib. Its argument is gonna be int n. And we want to really establish where that seeding, the base value is going to be the base case. So we would say if n is less than and equal to 1, it's going to return n. Okay, so what that does is it's going to establish the base for us. Then from the function, we simply just say return fib n minus 1 plus fib n minus 2. And why is this a recursive function? Because it is a function that calls itself. So in order to build out the subsequent value, it needs to build out the prior values, right? So it takes the prior values, sum them up together to get you the next value. So it is a function that calls itself. In the main, we would have the number that represent the position of the element that we want to find. So if I wanted to look at the Fibonacci number for at the 80th position, I would put 80 there, right? So in our assignment, we want to look for the 11th position. And we want to calculate that. So to display, we simply do a cout, and then we would say we're going to call the function fib that we previously defined, and then the n value, it's going to plug that in here for 11, and then that will be the end of our program. So it tells me after I run the program in that it would be 89 is the value at the 11th position for the Fibonacci sequence. So then you put that program into your IDE, and you don't have to use the .h. This is like if you write it in C. So for the top part, we simply just use IO stream and algorithm. Why are we using the STL? It's because we're using an equation. Okay. We put that into our IDE and we would run it. Now we don't have to use recursion, but you often see how recursion is used with Fibonacci, because it's by definition, right? We take the prior number and the number from two prior places and add them together, we would get the next Fibonacci number. So then what we would have is we can build out, we would be able to find the value based on the position. Okay. So we want to verify this with the calculation. So we would say that for Fibonacci sequence, we seed at 1 and 1. So 1 plus 1 is going to give us 2. 1 plus 2 is going to give us 3. And then 2 plus 3 is going to give us 5, and so on. So for the 11th value, we would have to take the 10th value plus the 9th value to give us the 11th value. So here we would have 89. And how did I get there? I have to be able to determine what my 10th value is and my 9th value is. And so my 10th value is 34. And how did I get 34? I have to know all the prior values, right? So as you can see, it has to recursively call. So the 11th value would be the 9th and the 10th value. So the relationship between this number and the two prior numbers is that it cannot yield, right, that number or any subsequent number without returning the value in the prior elements. So the way that we integrate the algorithm is in the function itself, right here. So when we define the function fib, if it's 1 and 1, it's going to return, and that's the initial, that's our base, as we said. When we return, we simply take the nth value and we plug that in. So, and then we call the fib function. So it's going to build on the prior results. So for the second part, you simply, after you calculate what that 11th value would be, okay, I want you to explain how Fibonacci equation is integrated into the program to derive the output. Okay, so focus on how that function is defined and how it is called. So we activate the light. Now, what if I wanted to find a later value in Fibonacci sequence? If I use the 18th, okay, as the question is asked, if we simply change the n value to 18, right, it should give us the number that's later in our sequence. So we would then put 18 here, and we run it. So it tells me that it's 2,584. Now, what happens if I put in 80? See how it's so now the compiler is then unable to give me the immediate value. Why is that? So there are two things that we need to consider to fix this, right? Because it is a recursive function. It needs to call itself. So in order to give me the 80th value, it has to build out, right? The 79, the 78, the 77, the 76, and all the prior values in order for it to give me the 80th value. So as you can see, now also, we also need to take a look at the data type, right? Because when we're at 18, it's already in the thousands. So are we're asking, is integers going to be enough, right? It should be, okay, for our data type. And so if you want to write a program that's going to hold a very large number for something that's down in the sequence, then we would want to consider using a different data type. So it would hold a large number. But as you can see, when you put in 80 for n, right? The limitation with recursion, we see that there. Okay. What about if we do 50? Let's stop that. Okay. What about if we do 35? And it all depends too. There are factors that we don't consider, like, you know, the processor, okay. So at 35, I'm able to get 9 million. Okay. So now if I switch this to double, right? If I type it as double, it's going to be able to hold more. And then in addition, I probably have to think about how to really make the program produce a little better. Okay. So recursion is going to run into problems when you're using it to find the later numbers. So when we edit our program to be n is going to be equal to 18, we should be able to get a result, right? Take a screen capture. Any question with 1? So in assembly, sometimes we also write Fibonacci in assembly too. So you can write it in any language, actually. You can either have it generate the sequence itself or find the number. Okay. No question on 1? Okay, so let's talk about number 2. So let's approach it a little differently here. And if you read the comments for this, right, we would have space optimization. We're going to use variables. So the way that we can store the value as we build it out, we would define variables to be able to add the sum for the immediate sum. So we temporarily store the value, and as we do it, we would update the variable. So compared to the prior example, you would see that this is slightly different. Okay. Now, if you look at the code, yeah, let's go through it. The top part, you are also going to have IO stream and algorithm and using namespace std. We're going to define a function called fib again, and its argument is going to be n because we're going to find the nth value. Then for our function, we are going to have four variables, I'm sorry, A, B, C, and I. And in this one, we are going to seed at 0, but it doesn't really make a difference in the entire program if you seed it at 1 or 0. So just to show, A is going to be 0, B is going to be 1. And then we're going to have C is going to store the sum of A and B. And we're going to have I for the index as we are going to loop. So this is an iterative program. Now we're going to have the base. So if n is 0, we're going to return A, which is 0. Then we're going to do for I is 2, I is less than and equal to n, and we're going to increment I. Why does it start at 2? If you look at the Fibonacci sequence, okay, look at this. The index at 2 is where you're going to see the sum of the two prior, right? 0, 1, 2. So I start looping here because I'm going to take the two previous value, add them together to get to the next. I don't start at the first index because what am I going to add together to get the first? You have to have the seed values in order to get to the next, right? So when it loops, it's going to start looping at index 2 and it's going to go to nth, right? Then because we're going to take the index 0 and index 1 and we're going to add them together to get to the first one, which is index 2, and then so on. Okay? So that's why we start here. So here in the loop, we're going to take C. It's going to store the sum of A plus B. And then we have to reassign as we have to move forward in the sequence, right? A is going to be reassigned to B and B is going to be reassigned to C because we have to progress in the sequence. So then the sum is going to become one of the value that we need to use to add for the next sum. And from the function, we want to return B, which is going to represent the value at the nth position. In the main, we initialize variable n, and we call on Fibonacci function, Fib function. So there, sorry, I want to check the value. I think I have 9, so I want to match up with what you have. So when I run this, I should have 34. Okay. Any question? So it's still going to achieve the same thing as what we've been working on in number 1, right? You're still going to be able to find the value at a certain location of the sequence. But in this one, we use loops. And since we're optimizing space, it's because when you're reassigning the value, right? It simply is a way for us to look at the variable and then associate it with that location in memory where it stores that value. Okay, so after we run the program, take a screen capture. Then we need to show the calculation. Just like number 1 for 2B, we are going to calculate the Fibonacci sequence. So for the 9th value, we're going to take the 7th value plus the 8th value, which gives us 13 plus 21, and that's going to yield 34. So as it loops through, it's going to sum the values together, right? The 2 prior, and it's going to put it into C, and then we would reassign, right, for each of the variable. So like number 1, I will need for you to explain how Fibonacci algorithm was integrated in the program, and want to focus on the fib function, explain how the loop works to be able to give you the output. Then after that, we would then edit the program, and we want to find the 14th term. So at 14, I should get 377. But let's say that I wanted to change this to 84. See if it's able to do. So as you can see in the iterative program, you're able to go higher. Okay. What about 184? So when you get higher, notice that this becomes what? Just address. Okay. Because it's not able to give you that. Possibly we have to change up we would need to change up our data type, right? And to be able to accommodate the later values. But the limitation for this is going to be higher than the last. Okay. So now you see a second approach in how to write Fibonacci program. And if you do take CIS7 with me next semester in spring, we will revisit this, but in assembly. So recursion is really easy to write, right? It's simple. There's not a lot to it. Now, if you do space optimization, you're going to get better time and then the result. Because here we allocate storage for values, right? Temporary, and then reassign those. So you would look at the relationship between space and time. So if it takes more space, then it's going to give you faster output. Any question? All right. So after we revise our program and produce the value for 14th position, you can test your program with different terms in the sequence, like what I did, 80, 50, 180, and see what it takes. And you want to compare exercise 1 and 2 and keep in mind about efficiency and the use of variables and functionality. So there is an indirect relationship between space and time, right? Where in that, if you give it more space, it's able to give you, right, better time complexity or time in general in the overall performance. The limitation between number 1 and number 2 that you saw is that in recursion, right, we are not able to achieve the later numbers as fast as what we expect. So to really fix that, instead of using a loop, you would want to consider having a temporary location where you would place the values so that way it can calculate. Okay. Or we can use either a container variable, or we can use ways to point to it. But simply how it's written, it's not able to achieve that in the later values. So I want you to compare 1 and 2, looking at how space is used, how efficient is the program, the functionality of the program. And just give me your comparison for E, 2E. So in this one, we see how variables can be used. Okay. And then we're going to take a look at another one that uses container, a larger container, which is your array. Question. Okay, so no question. So in number 3 is a little different than number 2. We only have 4 to do today, so fairly short. You're going to see that it's still going to iterate through and to be able to really build out your Fibonacci sequence. But instead of using variable, we are going to implement array. Okay. So we have a function called fib, and we are going to have the array that's going to store the Fibonacci numbers. And we have to have an extra space because it's going to handle the first value, the seed, which is 0. And instead of using the if, we simply define what they are. So f, at the index 0 is going to be 0, right? At the index 1, it's going to be 1. And then after that, it's going to loop. So in this one, instead of starting at 1 and 1, it's going to start at 0 and 1. And just like before, we are going to have a for loop starting at index 2, because that's where the sum is going to be, right? And then we're going to take, here's the Fibonacci equation. F of I is going to be f of I minus 1 plus f of I minus 2. And we're going to return f of n. And if you're using VS and it starts throwing crazy error because it doesn't like having an array that doesn't have, you know, a constant index value that's not initialized. A while back, a couple laps back, I actually put some information about dynamic array. If you're not sure, you can go back and take a look. Okay, how to create a dynamic array. You're gonna just need a constructor, and then at the end, you just need to deconstruct it. Then in the main, we specify what n is, and then we call on the function. So this one's still going to give us 34. For the 9th value in the sequence. So we would then need to show the calculation, and you can simply take what you previously written for number 2, right? F9 is going to be equal to F7 plus F8, which is 13 plus 21 gives us 34. And unlike number 2, we're using array to store Fibonacci sequence. So one of the big key area in programming is to really look at how you have where you store your data. So that way the data can be accessed. That's the important part, right? So your data structure, thinking about how you're structuring your data is essential. Okay. So now we can modify this and make this 18. And it's going to give me 2584. What if I have 80? Right? So here, as you can see, in the last program in number 2, when we did space optimization with the variable, right, it was able to handle 80 okay. Now, this is because when you see memory address like this, check out your data type. So the container, it reaches its limit. Or it's not able to compute, and then it's just going to tell you that, yeah, that's the memory location where I would put the value. but I'm not able to give you the output right now. Okay. So now if we go a little lower, 50, and run it. And then what about 35, which is what we tested with recursion, it was able to produce. So on VS, you're going to see that it's going to do a little better than what I'm using, which is REPL. Okay. But in general, you do have some limitation, even with this one. Okay. So as we build out that program, we're going to make an edit to n value, which is 18. After we explain how the equation works in the program, then you want to test it with a different n value and then make a comparison for the program 3 to program 1 and program 2. As far as how are they efficient, their efficiency level, the use of the variables or containers, and functionality. And of course, these programs always have room for improvement, right? We can further improve the programs by looking at the positive and the negative side of each program, looking at how data, the limitation of the data structure, how it's using the container. So the takeaway from this is when you're writing functions, whether it is for looping or for recursion, okay, when you're working with a large data set or something like a sequence like this, where it would build on the prior numbers, we have to really consider how we structure our data and what kind of function that we're writing to implement the algorithm. If we solve the problem, yes, it does work for most part at the beginning of our sequence, but later in the sequence, it's going to run into issues. Okay. So after you have explained and changed the value, then for E, all I want you to do is to provide me an explanation or a comparison for number 3 against 1 and 2. Any question? So in the next part, it's simply redefine recurrence relation, which is an equation that recursively defines the sequence where the next term is the function of the previous term. There is a linear recurrence relation. And sometimes that you would also see that it's represented in arrays. So it tells you here that an equation that recursively defines a sequence or a multidimensional array of values, once one or more initial terms are given, which is your base case, right? Each further term of the sequence or array is defined as a function of the preceding terms. And you would see linear recurrence happens, or it's applied to Fibonacci number, Lucas number, Padovan sequence, and Pell number. So in Fibonacci, you would see that the first two are ones. So it seeds at 1 and 1. For Lucas, same equation, right? But it seeds at 1 and 3. And then Padovan actually goes back 3 numbers instead of 2 numbers. And they're all ones at the beginning. So Padovan starts with 1, 1, 1. And then you take 1 plus 1 plus 1 gives you 3. I'm sorry, 1 plus 1 gives you 2. And then it's going to go 3 places. And then your Pell is going to be 2 times the one prior plus the value that's 2 places before. And it seats at 0 and 1. Okay. So remember that the recursion consists of a function that calls itself. And the recursive function is defined in terms of the base case and recursive step. So either you're going to have to implement some kind of condition in that function with the if. So the base case in recursive algorithm is the case that it's no longer recursive. And the good example for that is your factorial function. So in the base case, we would compute the result immediately given the inputs to the function call. Then the second part to recursive relation is that we would have a recursive step where we compute the result with the help of one or more recursive calls. So when you go into recursive step, that's when you call, it's a function that calls itself, right? That's when it calls itself. In the base case is where you would state the condition of your input in which it does not apply to the recursion. So this is a factorial program, not a Fibonacci program. Because I'm pretty sure by now you're tired of Fibonacci after 3, right? So for Fibonacci, you mostly see, right? You're mostly gonna see that people implement loops or they implement recursion to write Fibonacci sequence. So here on this one, very similar, right? You are gonna have a program for factorial. And you would include IO stream using namespace std. We are going to have a function called factorial. This is a prototype at the top, and then the definitions down here. So in the definition of the factorial function, we state our base. If n is greater than 1, we are going to return n times n factorial of n minus 1. else we're going to return 1. Okay. Then in the main, we are going to call, right, the factorial function in the print or the display of the value. So here we're recording an input. So enter the number that you want to find the factorial for. So in your assignment, your lab tells you that you would run the program, take the screen capture, and then you want to verify the program is correct. Okay. And we want to run the program and we wanted to see, so let's say we want to do 15. So the factorial of 15 is that value. We run it again. Let's say we go for 20. Now we only getting a memory address or the location. Okay. So how can we really improve this program is that we would want to consider having some kind of storage location, a variable, or something like that to be able to store the value as it calculates. Okay. And then we also need to consider our data type as the numbers would get larger for the later values of n. And that's going to present issues because integer that will max it. Okay. So after we take a screenshot, after we run the program, we wanted to verify if the number is correct. And you can put in whatever that you use for input, then you can calculate it. So let's say we use 4, right? Factorial of 4 is going to be 4 times 3 times 2 times 1, which gives us 24. And in our prior assignments, we talked about the advantages and the disadvantages of our recursive function compared to iteration. So you should know that by now. So for C, we want to explain how factorial algorithm is integrated to derive the output. We want to calculate for n is equal to 15 and 20 with the input. So run that and see what the outcome would be. I think it should go 18. It should be okay. I remember there's a, yeah. Let's see if we run it for 17. So anything from 15, anything from 15 for this program would, let me see if 16, yeah, 16 works. So anything above that using REPL would not work. But if you use Visual Studio, I think it, you know, it should still be able to produce. But when you're getting a negative sign in the front or like some kind of 0, X, whatever, that's just, it's telling you the location where it would place the value. All right, so after we test it with the 15 and 20, we want to explain the advantages, disadvantages of you using recursive function for factorial calculation and programming. Now, if we can also approach this using a vector, right? We can also use some kind of other form of data structure, looking at ways that we can improve it instead of using, we can do a loop with it. So there are quite a few ways to do factorial, but this is for recursion. A function that calls itself. So after this class, no more excuse on how to not know how to write recursive function anymore, right? I remember 17A, some of my students, they struggle with that. Question? Okay. Short and sweet, right? So if you do have everything for 1, 2, 3, and 4, that's it for our lab. Also, don't forget, there is a homework assignment. Okay, that's due on Sunday. Take a look at the homework assignment. It should be everything that we've covered in the last few chapters. So if you did those with me, you should be able to answer the homework questions. And that's just going to help you for our next quiz, which will happen next week. So I think we talked about some of the benefits and the disadvantages from, I want to say, lab 5 and 6. So you might want to take a look at those. Let me find it. Even before that, I remember that I put it into one of the labs. Let me stop recording real quick. Otherwise, people just have that sound.